This week we will learn about the logic gates and number systems, which is a really easy, comparatively easy topic. Okay, so we will learn about different number systems, and also we will learn about logic gates. It is comes under the electronics part. So there are number systems, different number systems. So we are using the decimal number system where we have 10 symbols. So we have 0, 1, 2, 3 like that up to 9. So we have 10 symbols. So we are using them to count numbers. So binary system has just 2 symbols. It has 0 or 1. So mostly we need to be familiarized with this one because we are going to use it here more. So in that case, so like in the decimal system, we start with 0, 1, 2, 3, 4 like that. And when it goes to 9, and after 9 we repeat the number. So we say 1 and a 0, 1 and a 1, 1 and a 2, 1, 3, 1, 4 like that. In binary, how we write it as, we have 0 and we have 1. Then we don't have anything else. We have 0 and 1. So when we go to the next one, it will be 1 and a 0. Then it will be 1, 1. Then it will become 1, 0, 0, 1, 0, 1. So do you see the pattern? So it's so if you compare the binary with the decimal, 0 is the same for both binary and decimal. 1 is the same, but when you go to 2, the 2 is equals in the decimal. The 2 decimal means base 10. 2 is equals to 1, 0 in the binary, which is with the base 2. Do you understand what I mean? So we can convert binary to decimal and decimal to binary, and we can find out which numbers are equal in the binary system and also in the decimal system. So we are going to learn how to convert binary to decimal, decimal to binary, and also we will learn about the octal number system where we have 8 symbols. So you can see it's only up to 7. The numbers are the symbols are 0, 1, 2 and up to 7. And also we have hexadecimal where we have 16 symbols. These are alphanumeric systems because we have not only the numbers, we have alphabet, the letters from the alphabet as well. So it has 16 symbols. After 9 it is starting A, B, C, D like that. Okay, so we will learn about the conversions after, like, to know how we can compare the numbers. Now let's see the place value. Have you heard of the place value of a number? So what do we mean by place value? Not the sign. It's like this. So we can have, like, you have done this, I think. So this is the place 1, 10, 100, and also when it after the decimal point you have 1 over 10, 1 over 100, 1 over 1000 like that. So these ones we call the place value. So similarly we have a place value for decimal. So can you tell, here we have 10. So if I write it, this will be 10 to the 0, 10 to the 1, 10 to the 2, and after the decimal you have 10 to the negative 1, 10 to the negative 2, 10 to the negative 3. So this 10, we have the 10 because we are using the decimal number system. When you use the binary number system, instead of 10 you have the base 2. So how should I write it? So if I ask you the place value of this point, it was 10 to the 0 in the decimal. So what should be the place value of that one in the binary system? 2 to the 0, isn't it? So base is 2 now, and the next one will be 2 to the 1. Next will be 2 to the 2. This will be 2 to the 3. Do you understand what I mean? And how about the other side after the binary dot? 2 to the negative 1. This will be 2 to the negative 2. And this will be 2 to the negative 3. Does that make sense? Okay, so that we call the place value. We should have, if we have octal has the 8. Hexadecimal has 16. So likewise, the base will be different depending on the number system. Okay, now let's see how to convert the binary numbers to decimal numbers. It's really easy. So if you consider this one is just 1, because, like, I'll do the B and I'll let you to do the rest of the things by yourself. So if you consider 1 0 1 0, we look at the place value. So this will be the place value, 2 to the 0, and this will be 2 to the 1, and this will be 2 to the 2, and this will be 2 to the 3. Am I right? So what that means? What is 2 to the 0? 1. And 2 to the 2, 1 is 2. This is 2 times 2, 4, and this will be 8. Agree? So look at this one now. So if you consider 1 has 0, so 1 times 0 is 0. Am I right? Then you have 2, but you have 1 there, and in this one 4 0, and if you consider this again 8 1. So what you do is you have this 2, 1 times 0, then you have 2 times 1, then you have 4 times 0, and 8 times 1. When you add all the numbers together, you will get the number in decimals. Do you understand what I did? Okay, so that will be here you have 0, 2, and 8. So this will be 10. So this is 10 in the decimal, and in the base 2 it is 1010. So 1010 in the binary system is equals to 10 in the decimal system. Make sense? Can I give you a few minutes for you to do the C and D? Bless you. Can you do C and D, please? I'll give you time. So to know which base it is, I'm writing it here. So you can see this is the binary system where you have the base 2, and this is your decimal system where you have the base 10. We don't write this base 10 in day-to-day life because we are always using the decimal system. But when we have different number systems, to make sure which one is from where, we need to mention which is the base. Make sense? Not the test, yes. Not in this coming test, but in the final exam, yes. And this is a very easy module. Included in the final test, yes. This is easy. This is an easy topic. Logic gates also very easy. So it's not hard. So which one you want me to do? Okay. So I'm going to explain the whole process again with the C. Okay, so we are looking at the different number systems. So in the binary, we have only 2 digits, 0 and 1. So these are binary numbers. So we have C, in C we have 1, 1, 0, 0, 1. So the place values for these numbers, so decimal, there is no binary dot here, binary dot if there is one, it should be here. So this place value is 2 to the power 0, this one is 2 to the power 1, this one is 2 to the power 2, this one is 2 to the power 3, and this one is 2 to the power 4. That means the number here is 1 and 2, 4, 8, 16. Am I right? Is that right? So 1, there is 1 times 1, and then we have 8 times 1 and 16 times 1. So that when you add all together, that will be 25. The rest is 0, so they are zeros. So no point of adding these ones. 4 times 0 is 0, 2 times 0 is 0. But you are adding the other numbers, 16, 8, and 1, which is 25. So this is place, you can write your answer like this. So you can say base 2, this is equals to 25 in base 10. Make sense? Are we good? You are adding together, yes, you are adding these together. Because I have 1 times 1. I have 8 times 1, 16 times 1. Are we good? Can you do the D, please? What did you get for D? So this is not 10,000, isn't it? This is 10000 to the base 2, which is equals to 16 in the base 10. Am I right? Is that right? Any question?
So only just one base 2 and 10?
No, I told you at the very beginning, we have octal number system where we have base 8. And hexadecimal number system, which is base 16. There are alphanumeric, there are different number systems. You mainly need to know about the binary and decimal. We are going to do if you want to, we will learn about the other systems in the coming slides, okay? It's not just 2 number systems, there are other number systems as well. I told you at the very beginning, didn't I?
Yeah.
I did. Yes, I did. Okay, so we have already done all this. Okay, now let's see. When we have decimal numbers or the fractions, how do we convert it? It's in the same way. Only difference is after the binary dot. After the binary dot, the place value, for example, if you have something like this. What was the place value here? 2 to the negative 1. What's that means? 0.5, isn't it? This one is 2 to the negative 2, which is equals to 1 over 4, which is 0.25. Am I right? And this one is what? 1 over 8. 2 to the negative 3 means 8, isn't it? That means 1 over 8, because this is the 2 to the negative 3, and that is equals to 0.125. Make sense? So you do the same procedure. So you consider the place value after the binary dot, and also you are adding them together. So in this case, if you add these two together, this is 0, so you don't need to add it. But you have this plus this when you add these two together, because you have 1 and 1 for those two place values, isn't it? So when you add these together, that will be 0.573. Am I right? So in the decimal, this is equals to that. Is that right? Five, 6, 7, and 3. Yes. So when you add these two together, you will get this. So 0.011 in the binary is equals to 0.375 in the decimal. Make sense? Okay. So can I give you time for you to do the A and B, please? And you have both. Okay. You know how to do before the binary dot. This part you know, and I just told you this part, and you just I want you to try this. Yes, so you do this part separately, the decimal part separately, and this part separately, and put these two separately like this. Okay? Okay, I'll give you time. Just do it and let me know. Can I know what you got?
159.55.
Which one is that?
Oh my God.
59.25.
Yes.
And the other one is 14.125. Did you get this or not? So where did you go wrong? 108. So the first one is you can ignore the front zeros. That doesn't mean anything. So this is what you have. Am I right? So this will be just, this part will be just 0.25. Why is that? 0.5 is 0 and this place value here is 0.25. So the decimal part is 0.25. Am I right? And the other part, what should it be? So this will be 2, this will be 1, 2, 4, 8, 16 and 32. So you have to add these ones, and this one is not there, it is 0. So when you add these together, 32 plus 16 plus 8 plus 2 plus 1 is 59. Am I right? So you have 59 and 0.25. When you add these two together, that will be 59.25 to the base 10. Am I right? So are you guys okay now? Okay. So I'll move to the next one. Any question? So this is easy, isn't it? Okay, now let's see how to convert the decimal to binary. Okay, so now to convert decimal to binary, what you do is you can use the same method to convert decimal to octal or else hexadecimal as well. So when you are converting decimal to binary, that we are starting with 27. You divide by the base. So we need to convert to binary, so we are dividing it by 2. When you're dividing it by 2, this will be 1 and 3, am I right? And you have 1 remaining, isn't it? So that one you are writing it here, the remaining one. And then you are again dividing this by 2, then it will be 6, isn't it? And again 1 is remaining, am I right? Then you divide this again 2 by 2, then it is 3, nothing remaining. So you need to put the 0. If there is nothing remaining, you have to put the 0. Make sense? And then you are dividing by 2, you get 1 and you have remaining 1. And you divide this by 2, nothing is there but remaining 1, isn't it? So you do this division till you get 0 and you write the numbers from bottom to top. That will give you the binary number. So 27 in the decimal is equals to 11011. So you start from the bottom and going up, okay, in the base 2. Make sense? Is that clear? So can you do, maybe you don't have to do all, maybe can you do 75 and 164? It will be the same. So can you do B and C, please?
So the binary is only base 2?
Binary is 2, yes. Decimal is 10. Octal is 8. So it's, if you want to convert decimal to octal, you have to divide by 8. Likewise, if you want to do it for hexadecimal, you are dividing it by 16. But you don't need to do that. Just get familiarized with the binary, converting decimal to binary. So you are not putting the decimal 0.5. You write the remaining one there. So it is 74 is what? 74 is what? 36. So 36 and you have 1 remaining, isn't it? So you write the remaining one separately. So you don't put the decimal. Is that clear? There are 2 ways that you can do. If you are not comfortable with doing this part here, you can ignore it, but you need to write from here to here. Okay, so you need to start writing from here to here. So you starting from here to here. Make sense? So you get the same number. If you don't want to divide the last 1 by 2, make sense? You have to write from here to here all these numbers. It's the same thing, isn't it? Make sense? Okay, so what did you get? Did you finish 75 and 164? Okay, so did you finish all 2? Okay, what did you get? Okay, so I have to delete this, my workings. Do you have this for 75? It is 1001011. Do you get it or not? Anyone got something else? Is there anyone who got something else? Yes.
I mean, it's 0, 1.
Which one you're talking about, 75? So 75, when you divide 75 by 2, what is it? 74, if you divide 74, that will be 36. But you have one remaining, isn't it? Okay, then you again divide this by 2. 36, when you divide 36, that will be 18, and there is nothing remaining, isn't it? Got it now? Okay. How about others? Can we move to the next part if you are okay with this? Okay. Okay, now let's see how we do the fractions. Okay, so 68, in this question I will do one and I want you to do the other one. So this 68 and 43, you are fine with that, am I right? 68, how to convert 68 to binary and 43 to binary, you are fine with that, and I will let you to do it later on. And now let's see the decimal side. So to do the decimal side, what you do is you multiply it, you multiply that by 2. So when I multiply 0.5625 by 2, what that will be? 1.1. Okay, so I keep this. Okay, so this one is there. I ignore it, and it will be there, and I'm just multiplying this by 2 now. So when I multiply that by 2, I have 0.25. Am I right? So I again need to keep this one separate, and I times this by 2. Then I get 0.5. Am I right? So I keep this and multiply this by 2. Then I get 1.0. Am I right? So you have to do it till you get zeros after the binary dot. So I don't have anything else, just the zero. So now I have these ones separate. So these ones, you just write these ones, that will be your decimal part, and you write top to bottom this time, not bottom to top. So you are okay with 68, so I'll let you to do the 68, and you have the binary dot, and you have 1001, and that will be your this part converted to the binary. Make sense? What we do, we multiply by 2 till you get 0 decimal after the dot, zeros. Make sense? Can you do the do 43.625? Final answer is I need to do the 68. So 68 you divide by 2, and that is 34, 0, and you divide by 2, that will be 1 and a 7, 0, and you divide by 2, that will be 8 and a 0, 1, and divide by 2, that will be 4 and a 0, divide by 2, 2 and a 0, divide by 2, 1 and a 0. So that will be, your answer will be 1000.1001. 68 I did in the same way that you did before, and the decimal part we have to multiply by 2 till you get 0, and that top. So this one is bottom to top, and this part is top to bottom. Make sense? Any question? So this will be the decimal part, how you do the decimal part. And this will be your whole number here. Which one you want me to do?
The one before decimal. 1 triple or 1 double.
That one you did before. You times by 2. You divide by 2. You did it in the previous one. You divide the number by 2, considering the remaining part. Didn't we do that? In the previous one, how to convert 68 to binary. How we convert 68 to binary? You divide by 2 till you get 0 at the bottom. That is not new. We have already done the 60. Do you want me to do it again?
No.
Okay, so how 43, can you do the 43 please? How we do that 43? I will do it again after you try. 43, just do the 43 first. And after you finish, only you can do this one, okay? 0.625, leave it. Just do the 43 because you have already done that. Okay, let me see what you got. What did you get for 43 when you convert 43 to binary? What did you get? 101011. Do you all get that? How about the decimal part? How do we convert the 43? Yes, so 43 you need to divide by 2. So that will be 2 and a 1, 21 and 1. And you divide this by 2, then it will be 10 and remaining 1 divide by 2, 5 and 0 divide by 2, 2 and 1 and divide by 2, that will be 1 and a 0. So 43 you can write it as 101011 in the binary. Are we good? How about the next one? 0.625. You times by 2, then you get 1.25, and you leave this and you times this by 2, so that will be 0.5. You times this by 2, then you get 1.0, isn't it? And you get 0 here, so you will write it as 101 in, you get this, am I right? Then you add these two together, then you will get 101011.101 in binary. Make sense? Any question? Or good? Can I move to the next part?
So now we stop at decimal when we get 1.
You can do in two ways, as I have told you. You can divide by 2 and then you will get 0 and 1, all the same. It's the same thing. Can I move to the next part?
Yes.
Decimal to hexadecimal. I want you to try this. So how do we do? Here you are dividing by 16. Hexadecimal is 16, isn't it? So you divide by 16. So how do you divide by 16? 4, 7, 6, 8. You divide by 16. What do you get? So you can do it in this way. So when you divide 4, 7, 8, 6, 8 by 16, you get 298. Am I right? And nothing remaining. Am I right? So it is 0. Now you can divide this by again 16. So when you divide this by 16, you have 18 and you have here. Now see what I'm going to do. You have 0.625. Am I right? So this 0.625, you are not going to put it as a decimal. You need to make it to a remaining number, isn't it? So that means if you times 0.625 by 16, that means 10, remaining 10. Agree? So you times this by 16 and you get 10. So that is the number which is remaining, isn't it? Do you agree with that or not? Then you divide this by 16, 1 and How many remaining? 2 remaining, isn't it? Make sense or not? Now this 10, so in the hexadecimal 1, 2, 3, 4, 5, 6, 7, 8, how the hexadecimal, what are the symbols in the hexadecimal? You have 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, like that, isn't it? So this is 1, this is 2 in decimal, 3 in decimal, 4, this is 9 in decimal, this is 10 in decimal, 6, 11 in decimal. So when you have 10 here, that is A, isn't it? Am I right? So you can write it top to bottom again. That will be 1, 2, A and 0. Make sense? Is it clear or not? What you do is you divide by 16. So when you divide by 16, you need to write the remaining parts. So if you divide 298 by 16, it has 18 and a remaining part. 10 remaining, isn't it? You can divide 288 by 16. It is 18, but you have 298. That means you have 10 remaining, isn't it? Make sense? Any question? You can find the remaining ones in this way. That's what I was telling. So if you have a decimal, you times the decimal by 16 and you can find this. But you can't write 10 because you don't have a 10 in your, you have a 10 but it is not the real 10. So this will be 10 represent A in the hexadecimal, isn't it? So you have to write 10 instead of the A instead of the 10. So you write it in this way. So this is equals to this. Can I give you a few minutes? Can you do 159, please?
So when you get the item, how do you get the result 1, 2, and 1?
Because you have remaining 10 here. 10 represent A in the hexadecimal, isn't it? What do we mean by hexadecimal? You have 16 digit symbols. So after 9 you have alphabet A, B, C up to 16. That's how the 16 symbols comes, isn't it? I told it at the very beginning if you remember. Is that right? So what are the number systems we have? We have so many number systems, but we have done binary. Binary means what? You have 0 and 1, isn't it? Only 2. And decimal means what? You have 0, 1 up to 9. So 10 digits. Here you have only 2 digits. Here you have 10 digits. Octal means what? You have 0, 1 up to 8. So this one has 8, sorry, not 8, 7. Up to 7. So this one has 8 digits that we call the octal number systems. Hexadecimal OS, yes, hexadecimal is 0 to 9 and then you start A, B, C, D, E. So all together you have 10, 11, 12, 13, 14, 15, 16 symbols. So that we call this hexadecimal number system. Make sense? Is it clear or not? So if you want to convert to hexadecimal, a decimal number to hexadecimal, you need to divide by 16. If you want to convert it to a octal number, you divide by 8. If you want to convert it to a binary number, you divide by 2, isn't it? So you divide by the base. Make sense? Can you do 159 and 215, please? I'll give you time.
So what's the final answer in there?
A? I wrote 1 to A0.
Yeah, I0 we know it, but 1 to we don't know where's
So what we need to do to convert decimal to decimal to hexadecimal, what we need to do? Tell me what we need to do. You divide by 16. So I'm going to divide this by 16. Okay, so we have 4, 7, 6, 8. We need to divide by 16. Okay, so when I divide 4, 7, 6, 8 by 16, what do we get? 298.0, nothing remaining. So we have 0 here. Am I right? Then I'm going to divide this by 16. So when I divide this by 16, what we will get? 18.625. Okay, so this is your number. So this came because of the remaining part. So what I did is I did multiply this by 16, then I got 10. So that is the remaining part. So I can ignore this one and say that when you divide 298 by 16, it is 18 and 10 remaining. Okay, now I again need to divide this by 16. If I divide 18 by 16, what should I get? 1 and remaining 2. Yes, 1 remaining 2, isn't it? 16, 18 if you divide by 16, 16 and 2 remaining. So am I right? So you have to do this till you get something less than 16 in this case. If you get something less than, in the previous one you have divided it till you get 1 or 0, isn't it? But here you can divide it till you get something less than 16. But here, like, you got 1 here. So that you are writing in this way. So 10 represent A, isn't it? So you will write it as 1, 2, A and 0, bottom to top. So this is 1, this is 2, this is A and 0, top, bottom to top. Are we good?
This whole question mean when we divide 159 with 16, I got 9, and then can we still calculate after that, or we stop at 9?
9, you stop at 9, yes, because stop at 9, yes. Then you start with 9, 9 and going like that. Make sense? I'll give you time for doing the B and C. Okay, so let's do the 159. So how did you do the 159? When you divide 159 by 16, what do you get? 9 and how many remainings? What's that? 15. Do you all get this? What do we mean by 15 then? A, B, C, D, what do you get by 15? It is E, isn't it? 15 means E. Am I right? So you have 9 and E. So you write this way. So that will be equals to 9E in hexadecimal.
A is 10, right?
A is 10. A is 10. A, B, C, D, E, F. So this is 10, 11, 12, 13, 14, 15. Yes, 15 is F. Yes, that's my error. 10, 11, 12, 13, 14, 15. Is it? A, B, C, D, E, F. 10, 11, 12, 13, 14. Yes, so it's 15 is F. You start at 0. 0 is a number. You have 0 in the decimal as well. So decimal also start at 0. Hexadecimal, everything is started at 0. So Alice, what was your question? Okay. Are we good? How about the 215? Okay, let me check. So we have 215, we divide by 16. So when you divide by 16, so
This is what if I forgot the alphabet. Will you write the alphabet in the test also?
we can put you into the kindergarten.
A, B, C, G, A, C, C. Yeah, that's what it counts. A, B, C, D,
7 remaining, am I right? So 13 is D, isn't it? So D7. Is that what you said? Okay. So 16. So are we good?
So in the final exam, you just look at the result, or you have to look at the portion?
If your final answer is correct, you will get the full marks. If your final answer is wrong and if you haven't done your steps, you will lose whole mark for the question. At least if you have done some steps, you will get some marks if you have the steps. But if you are confident, you can just you can just write the last answer. You will get full marks. 13 is D. Do you agree with it? Oh, I have wrote it there. So 13 is D. 13 is D. So this is D. You write top, bottom to top. So D7. A is 10. You know, A is 10. Zero is 0, yes. Both the number systems have 0. So start with 0.
So there's no
You have F for 15. F is 15, D is 13. Okay, are we good? Any question regarding number systems?